Hello everybody. Welcome from HVACR Design Engineering. I am Tuyao. Now I want to talk about apply Ohm Law. Ohm Law is relationship between voltage, current, resistance and how they relate to each other. Ohm Law was developed by German physicist named George Simon Ohm. The three formulas for Ohm Law are voltage V equal to current I multiplied by resistance R. Current I equal to voltage V divided by resistance R. Resistance R equal to voltage V divided by current I. We need to remember is Ohm Triangle. You just need to remember these three letters in order VIR. Then we write those letters in a triangle with V at the top and then we draw line to separate the letter. So we want to find voltage. We cover up the V in the triangle that leaves us with I and R. So we write I multiplied by R, which means voltage equal current multiplied by resistance. You can write a little multiplication symbol and division symbol in the triangle between the two letters will help you remember. If we want to find current, then we cover up the letter I in the triangle that gives us V and R. So we can write V divided by R. Therefore, current is equal to voltage divided by resistance. If we want to find resistance, then we cover R in the triangle that leaves us with V and I. So we write V divided by I, which gives us resistance equal to voltage divided by current. Let's say we have simple electrical circuit with a battery and a resistor. We don't know what the voltage of the battery. The resistor is 3 ohm. When we connect a multimeter into a circuit, we see that we get 2 ampere of current. Find the voltage. So, using Ohm Triangle, we cover up the V and that gives us V equal I multiplied by R. We know that current is 2 ampere and we can write that in and we know that the resistance is 3 ohm. Therefore, 2 ampere multiplied by 3 ohm gives us 6 volt. This 6 volt is battery voltage. 2 6 volt battery in series, we get 12 volt. If we connect this to the same circuit, the current also doubles the 2 ampere to 4 ampere. If we double the voltage again to 24 volt, the current will also double to 8 ampere. We can see that current is therefore directly proportional to voltage. If we double the voltage, we double the current. Remember, voltage is light pressure. It pushes the electron around the wire and we place thin light lamp in the way of this electron so that they have to flow into the lamp and that causes the lamp to light up. By doubling the voltage, we see the current also double, meaning that more electrons are flowing and this occurs as we apply more pressure on more voltage. This is just like If we were to use a bigger water pan, then more water will flow. Let's say we have a 3 ohm lamp connected to a 6 volt power supply. To find the current, we write down kappa I in the triangle that gives us V by R. So current equals voltage divided by resistance. We know the voltage is 6 and resistance is 3 ohm. So the current is therefore 2 ampere, and that we see on the multimeter. If we double the resistance to 6 ohm by adding another 3 ohm lamp into the circuit, the current halves such as 1 ampere. If we double the resistance again to 12 ohm, the current will halve again to 0.5 ampere. We can visually see that the lamp will become less bright as the current reduces from the increase in resistance. The current is inversely proportional to the resistance. When we double the resistance, the current will decrease by half. If we halve the resistance, the current will double. Let's say we have resistor lamp connected to 12 volt power supply. We don't know how much resistance is added to the circuit, but we measure the current as 0.5 ampere. To find the resistance, we cover up R in the triangle. We left with V and I. So resistance equals voltage divided by current. We know the voltage is 12 volt and the current is 0.5 ampere. So 12 volt divided by 0.5 ampere gives 24 ohm. Resistance is the opposition of electron. It tries to prevent electron from flowing. That's why we use resistor in circuit to reduce the current and protect the components such as light emitting diode LED. We try to connect LED directly to a 9 volt battery. It will blow up because the voltage and the current are too high. But when we add a resistor into the circuit, the current and voltage are reduced. So LED are protected and shine brightly. Increase the current by increasing the voltage, or we can increase the current by reducing the resistance. We can also reduce the current by increasing the resistance. Thank you very much for watching my video.